So, looking at this first term, looking at this first quadratic. Last week, how did we go about factoring quadratics like this? Boys in the back. AJ, I need you to stop. I'm done. Throw it away if you don't like it. You don't have to yell at the entire class about it right now. AJ,
I'll make that sound. It's supposed to be soft chocolate. Break.
You are disrupting the class. You need to stop. So, last week, when we have a polynomial that's a quadratic, 3 terms, and it didn't have a GCF, we didn't have something that went through all 3 of these terms. We looked at the last term, and we put that in the top of our x, and we looked at the middle term, and we put that in the bottom. So we have negative 48, and we have 8. And we were trying to think, okay, what 2 numbers multiplied to get your numerator, what 2 terms multiplied to get your top number, that negative 48, but add together to get the bottom, the 8. So what are some numbers that can multiply to get negative 48, but add together to get 8? And it got a little bit harder when we had a negative. So if this is negative, and this is positive, what does that mean about our 2 numbers we're going to get? One's going to be negative, but one's going to be positive. So what are some factors of 48? What are some numbers that can multiply to get 48? 8 and 6. Can we combine 8 and 6 somehow to get 8 though? No. So we'll have to think of some other ones. What are some other factors? What are some other factors of 48? 9 and 4 give you 36.
8 and 8.
12 and 4. Can we combine 12 and 4 somehow to get 8? And we have a negative 4 and a positive 12. These can combine to get 8. Good. So from here, what we saw is all we had to do was rewrite it as x minus 4 and then x plus 12. Sorry, that was the minus 4. X minus 4 and x plus 12. So this is what we talked about last week with our factoring polynomials. Looking at that second warm-up, x to the third minus 2x squared. We didn't factor this with our quadratic method that we did right here. What did we look for with this second one? This is what we did on last Monday, so I know it's been a week. Was it last Monday or last Tuesday? Sorry.
Probably last Monday. It's Tuesday.
We didn't have, yeah, Tuesday. So, what do you notice about this second one? An x. So with polynomials like this, we look for a GCF. So we call that a greatest common factor. What was a common factor in all of these terms of that polynomial that we could factor out with each of them? So what do you see you need to do? They both have an x. Can we get something even greater than just an x?
A y.
Does anyone have y's in them?
No, but 1 will work.
So 1x, anything better than 1x? So this one has a 2 in it, but this one doesn't. So we don't have a coefficient. What's your minimum value of x's? What's your minimum amount of x's in each term? X to the second power. So they both have at least x to the second power. So we can factor out x squared from each of these terms. And once again, once you figure out what you're factoring out, we then look at that term and divide it. So x to the third divided by x squared gives you just a single x. Minus 2x squared, if we divide that by x squared, that just gives rid of our x squared, so all we have is a minus 2. And that was our GCF that we looked at earlier. We pulled out that GCF, and then we had our factor left over. Are we okay with these 2 methods of factoring that we talked about last week so far? Not the second one from Tuesday? So, we saw things like 4x to the third minus 2x plus 8. Then we look, okay, what is our greatest common factor that shows up in all of these? Not all of our terms have an x in them, because this one doesn't have an x, so we can't pull out an x, but what do all of them have in them? All of our coefficients are divisible by 2, so we could take out a 2 from each of them. And then we saw, okay, if I divide this by 2, it's just 2x to the third. If I divide this by 2, it's just a negative x. If I divide this by 2, it's just a positive 4. So sometimes they had an x in them, sometimes they didn't. Sometimes you had multiple variables, like they both have like an x and a y. But you're just looking for what is saying about all these polynomials I can pull out from each of them, and then you just divided each of them by that factor. Is that okay, helpful? Kind of. You won't see these ones as much, but it's just helpful because if you can find a GCF first, that always makes your problem easier. If you can find a GCF first. All right, now something we were doing last week, we were looking at trinomials, quadratics. Trinomials have their 3 terms. It's always ax squared plus bx plus c, where a, b, and c, these are just some number. It could be 1, it could be 2, it could be 0, it could be 47, negative 34. Boys, let's stop. Put those away. You don't need them. You don't need them. Put them away. You'll learn that next year. Like either throw them away or give them back to action so you can put them away. You don't have to throw it. I gotta give it back to them. So, we were dealing with these quadratics last week. The thing is, all of the quadratics that we saw, all the trinomials that we saw, they didn't have an a. We never had a number here. It was always 1 for us. It was always an x squared was the leading term. So, we're going to figure out today, how do we deal with quadratics that have this leading term? What happens if there's a number in front of that? What happens if it's 3x squared? What happens if it's 7x squared? What happens if it's negative 2x squared? We're going to figure out what do we deal with when a is a number that's other than 1. That's what we're going to talk about today. Let's see, 2 weeks ago, I think it was, 2 weeks ago, we were talking about polynomials. And we were talking about multiplying polynomials. We did the foiling. So when we FOIL these polynomials, when we do like the double distribute of these polynomials, all of the answers we had in the past were always x plus something or like x minus something. It was always x and a number, x and a number. So what happens if we have 3x plus 2 compared to just a single x plus 2? And so when we multiply by a 3x, when it has a coefficient in front of it, that's when we're going to get our number that's going to have the number in front of a. That's when we're going to get that leading coefficient other than 1. And so that would be 3x squared, and then 3 times negative 4 would be negative 12x. 2 times x is just positive 2x, and then 2 times negative 4 is negative 8. Once we multiply those, we combine them together, and we get 3x squared. Negative 12 plus 2 is 2x. Negative 12 plus 2x is negative 10x. And then minus 8. So that would be our factors. After we took our factors, we multiplied them back together. That's what would be our answer. Using our normal method we learned last week, that x method, if we create an x for this problem, and you put your last term in the top, and your middle term in the bottom, what are 2 numbers that multiply to get negative 8 but add to get 10? Actually, 2 numbers that multiply to get negative 8 and add to get negative 10. What was that? There aren't none, but there has to be. This has to be the way we do it, right?
No, Jarvis, there isn't any.
All right, so here's the thing to notice. If you have a leading coefficient, this method will not work like normal. We have to change it a little bit. So you can't just use the method we were doing last week. So it's going to get a little bit harder, but it doesn't change by much. We're still going to use this, but we just have to change the steps a couple of bit. So let's start with this one. We have 5x squared plus 11x plus 2. If you have a piece of paper, I would recommend writing along with this one, just so you can get familiar with these steps. Rather than creating that x like normal, we're gonna still create the x, but we're gonna do one thing different. That middle number is still going to be at the bottom. But rather than just taking my top number and putting it in the numerator, just taking that last number, I'm going to take both of these, both my first and last number, I'm going to multiply them together. So rather than just taking 2, I'm going to take 5 times 2. So that'll change how we figure out those numbers. So what are 2 numbers that multiply to get 10, but add to get 11?
1.
1 and
10.
1 and 10.
Good, done.
So from here, in the past, we would just jump to x plus 1 and x plus 10. But the thing is, in order to get that leading coefficient, we always have to have a number in front of one of these x's. So this can't be our solution. We can't just jump straight to here right now. That only works if we don't have a number in front. So this technique that we're going to use is going to be called split the middle. And the reason is because we're going to split that middle term into 2 pieces. So we are going to try to split this middle x, this 11x, into 2 pieces. So we saw that 10 plus 11, or sorry, 1 plus 10 equals 11. So I'm going to rewrite this as, instead of 11x, 1x plus 10x. So I have my 5 squared still. I'm rewriting 11x as 1x plus 10x, and then plus 2. So I rewrote the equation. Rather than having my 11x, so I split it into 2 pieces. I split that middle term. That's where we get the name from. Are you okay with this so far?
Yeah.
All right. This is where it's going to get a little different. Now that we split this middle term, I'm going to group it. I'm going to group my first 2 terms in parentheses. And then I'm going to group my second 2 terms in parentheses if my thing stops freaking out on me. Get this. Alright, so plus. So after you split the middle, what we do is we group that first group, those first 2 terms together, and we group the second 2 terms together, the last 2 terms. So on my 5x squared plus 1x, and then 10x plus 2. With each of those groups, we are going to look for a GCF. So looking at just this first group, 5x squared plus 1x, do I have a greatest common factor? They both have an x in them. 5 and 1, I don't have a greatest common factor from that, so I can factor out an x from each of these terms. So if I factor out an x from this, if I factor out an x from my 5x squared, that just leaves me with 5x. If I factor out an x from my 1x, that's just plus 1. So I factored out my x, my GCF from both of these terms. I need to do that with my second group as well. Do I have a GCF of my second group?
No. No, yeah. 10.
So 10x plus 2,
2.
they're both divisible by 2, so I can factor out a 2. So 10x divided by 2 is 5x. 2 divided by 2 is just 1. So I factor out a GCF from both of those 2 groups. What do you notice is left over? If I were to distribute, I would get back to what I had before. What do you notice similar about each of these groups? One is a 5x plus 1. This one has a 5x plus 1 in the parentheses. So because they're both 5x plus 1, my 2 factors, my 2 answers, is going to be what's left over on the inside, 5x plus 1, and then what I have on the outside, x plus 2. And those are my two solutions. So this is our split the middle. We only need to use this when x, or when that number in front of your x squared isn't 1. So if there's a number in front of the x squared, that's when we have to use the split the middle. But if it's just 1, we can use that quick method we were doing last week. But once again, just to run through the steps. We created our x like normal. We multiplied the two numbers in the top, our last and first number, to get 10. We looked for the middle number, found our two factors. 1 times 10 multiplied to get 10. 1 plus 10 gives you 11. We split the middle. We rewrote 11x as 1x plus 10x, our two factors we found. Grouped our first and last terms. Found a GCF of the first group. Found a GCF of the second group. And then your answer was, those middle two terms should always be the same. So that was one of the answers, and then whatever on the outside is the rest of it. So 5x plus 1, and then x plus 2 are your two factors. So there might be a lot of steps at the moment, but the more you get used to it, the more problems we do, the easier it will become, the easier these steps will start coming to you. Are we okay with this for now, or is there anything that was like super confusing at the moment?
No.
We can do another one together as well.
Oh, yes, please, thank you.
Yep. No. All right, so once again, first thing we do, create that x. I'm going to take my first number and my last number and multiply them together. So 6 times 5 is 30, and then my middle number goes in the bottom. So I have 30 and 13. Two numbers that multiply to get 30, add together to get 13. 10 and 3, is that what you said? So they add together to get 13, multiply to get 30, good. So now that we found those two numbers, we split the middle. So rather than writing 13x, I'm going to write 10x plus 3. So 6x squared plus 10x plus 3x plus 5. Something you might notice. What if I thought 3 plus 10? Or 3 and 10 rather than 10 and 3? What if I had these flips? What if I wrote 3x plus 10x? It's still right. Your factors might turn out to be different, but your final answer should still be the same. So even if you switch these numbers, if you wrote 3x plus 10x rather than 10x plus 3x, you'll still get the same answer. You'll still get the correct answer. Your work just might look a little bit different because your numbers you factor out might be a little different. And that's okay. So don't freak out if your work looks a little bit different because you switch those numbers. Thank you, Riley. Oh, I'm sorry. Sorry. You guys sounded similar. It was like the. All right. Once we split the middle term, once we split that, we grouped it. We grouped our first two terms. We grouped our last two terms. So that's 6x squared plus 10x. I grouped that. And then I had plus my parentheses, my 3x plus 5x. So I split my middle, I group my terms. Next step is we look for a GCF. So looking at this first group, do I have a GCF? So 6 and 10 are both divisible by 2. Is there anything else? X. That first group, the nice trick is that first group will always have an X no matter what. You'll always get a factor of an X. So this one's going to be 2x. If I factor out a 2x, 3x squared divided by 2x, 6x squared divided by 2x will give me a 3 and then an x. 10x divided by 2x will just give me 10 divided by 2 is 5, and the x is canceled. So I factored out my 2x, and I have 3x plus 5 just left in. Looking at this second group, what's my GCF I have? 3x plus 5. What GCF do I have? There is no GCF. So if I can't factor out anything, what do I factor out?
X.
Just going to factor out 1. Because technically 1 is a factor. It's not really considered a greatest common factor because it's always our least factor, but it still is a factor. 1 still goes into 3x, 1 still goes into 5. And so if you can't find a GCF from that term, you can just factor out 1. So if you don't find anything, just factor out 1, you'll still be okay. But once again, that first term will at least always have an x no matter what. AJ, let's go back to your seat, please. Oh, you don't need to check your phone right now. Thank you. You don't need to check your phone. You can go without 5 minutes without worrying about it. Okay, that's fine. You can still go longer. All right. Now that we have those 2 GCFs, our last answer, our last step, we took the outside as one term, 2x plus 10, and then the inside should always be the same as your second factor. So 3x plus 5 and 3x plus 5. That is our other factor. And then that was your answer. Once again, if you want to check to see if this was correct, you can multiply this back out. You can distribute that back out, and you should get your answer you just started with, or your beginning solution. Do we have any questions over the steps we took at the moment? So once again, start with that x. Multiply your first and last term to get the first number. Your middle term, once again, is your bottom. Look for 2 numbers that multiply and add to get those 2 terms. We split the middle. Then we grouped, found our GCFs, and then the outside was one answer, the inside was your other factor. And this will work for any quadratic you run into, assuming it's factorable. There are some quadratics that you just can't factor. There's just no numbers that work. Like that one we saw earlier, sometimes there's just not numbers that work. That's okay. Those are just unfactorable. There aren't solutions for them. But you shouldn't have to run into those with me. So don't worry about that. All right. I want you to try this first one on your own. If you get stuck on the steps, if you're confused on what the next step is, let me know. I will help walk you through it. Let's see if you can factor this first one using that split the middle. Let's talk about this again. So, I know, once again, there's a lot of steps involved with this. It's hard to keep track of all those steps. But once again, the more we do it, the more you get used to the steps, the easier it will become. This is the only thing we're learning this week, because it's combined with what we learned last week. It's the only thing that's going to be on your assessment along with what we did last week. So, you have that to look forward to. We'll have a lot of practice this week. All right, so once again, we start with our x. We look for what 2 terms multiply, or we take our first and last term. We multiply those together for our top term. So 2 times 6 is 12, and then our middle term goes in the bottom, so 13. Were you able to find one? Cool. So, we have those 2, take your first and last, they multiply to get 12. Our 13 is in our bottom, that middle term is in the bottom. We have to take 2 numbers that multiply to get 12, add to get 13. 12 and 1. Now that we have our 2 terms, we can split the middle. So we're going to take that 13x and we're going to split it into a 1x and a 12x. So I'm going to rewrite this whole thing as 12x squared. I'm going to split that middle term. So rather than having 13x, I'm going to have 1x plus 12x. And then plus 6. So I rewrote my whole quadratic by splitting that middle term. After we split the middle, we grouped our terms.
That's being a distraction. Allie, that's why I was here.
Go back to your seat if you're distracting them.
Well, she is videotaping people to a live thing, and then.
All right. Ashton, just go back to your seat, please.
You're making excuses. You need to make better ones.
Yeah, you need to get.
Or we can just stop making excuses and just sit where we sit.
I'm not making excuses.
All right, just go. Go.
Come on now. Back to your seat. Sit down.
12x squared plus 1x plus 12x plus 6. We split that middle term. Once we split the middle, we grouped. We grouped our first 2 terms. We grouped our last 2 terms. So this is 12x squared plus 1x, my first group, and then plus 12x, sorry, I keep saying 12x squared, that's 2x squared, plus 6. So we grouped our first terms, we grouped our last terms. Then we looked at each of these groups and we found a GCF. What is my GCF of this first one? So they have an X, but that's the only thing that's in common. It's a 12 and a 2, a 1 and 2, so we can just get an X. So if I factor out X, 2x squared is just going to become 2x. 1x,
That's pretty good.
1x, if I factor that out, is just going to become 1. So I factor out each of those terms, that GCF. Then I look at my second one. What GCF do I have of this?
6.
So they both have a 6 in them. This one has an x, this one doesn't, so it's just going to be 6. Then I factor out my 6. 12x divided by 6 is just 2x. 6 divided by 6 is just 1. Once again, these middle insides should always be the same. If you have something that's different, then we have to go back and check those factorings again. So these are the same. So then my final answer, one factor will be the outside, so x plus 6. And then the other factor will be the inside, 2x plus 1. And that's our split the middle. Once again, I know there's a lot of steps. I know it's a lot to work through. But the more we do this, the more we get used to it, the easier these steps will start coming. This is the only thing we're doing this week, so we'll have a lot of time to practice, a lot of time to go over it. Let's see. 104. All right, we have one more time to do one more. Do you want to do it together or on your own this time? You want to try one more on your own? All right. Once again, if you have questions, let me know. I will try to do my best to walk through with you.
Oh.